introduce our next speaker, which is Brian Su from Preen, and he's going to be doing a discussion on understanding AC power sources. Brian is originally from Taiwan, and he has a double master in mechanical engineering and environmental engineering. And he was the product marketing manager the last 5 years at Preen AC Power Corp. And he's worked in several industries in hardware, software, and lots of power electronics. So with that, the floor is yours, Brian.
All right. Yeah, hi everyone. So today we are going to understand more about it. Typically we use power supplies like AC power source, DC power supply for your testing purpose, or either for your for small one, maybe for your computers, from all the embedded systems. But today we're gonna have a presentation and discussing like what different type of power supplies and what kind of different types of applications. Because usually, from my point of view, a lot of like users, because they have different kind of applications, but they may suitable for different power sources. But sometimes they don't understand the different type, what's the difference of that. So we will spend some time there. And yeah, so thanks for Gab's introduction. And our company based in Taiwan, and we have a US branch in Irvine. So we manufacture power products since like 1989. So we start from like power conditioner, power source, frequency converter, all the way to DC power supply for different applications, for the military, for aerospace, for the show power. So when you take a look at the chart over here, you will see actually power supply. Typically we hear about power supplies maybe in the test and measurement part. So here, like, if you are in test labs, you use like a lot of programmable power supply, power source for changing either for do the compliant test, IEC compliant test, or DO160 standard. So you need a compliant test for the labs, ATEC system, or like compliant test of production lines. So these are testing power supply, or the test and measurement. But the other part of the power supply used is like sometimes we call it power conversion. It's usually, what's the difference with the testing and power conversion? Testing power supply, usually you need more features, or first thing you have to idea is like testing power supply usually need like adjustable voltage, adjustable frequency, because you can do the upper bound, lower bound, and boundary testing. So you will not just like you need something like 110, but something you need to test plus 15%, minus 15% of the voltage, or frequency. Sometimes you have to do an upper bound, lower bound test. The reason why we need to test the upper bound, lower bound is because usually the product in the upper bound, lower bound, the performance will be very different. So you have to make sure your product is working well in different power conditions when you ship out to all around the world or in different country area. And because the voltage, you cannot guarantee in your test lab, it's always in 220. Sometimes 208 maybe drop down to like 190, may go up to 240. You want to make sure your product is working well in that kind of circumstance. So the power conversion is kind of different way. Usually for power conversion application, you just convert from different voltage to, for example, like 208 to 380 or 480, that kind of voltage. And the frequency may be from 60 here, but in the military they need 400 hertz. So you may convert from 60 to 400 hertz. So that kind of application can be embedded in a product, like in a radar system, like in a missile system, or like in a vehicle, or in an EV car. So in the marine or aviation, sometimes medical equipment like MRI, you need power conversion as well. So it's kind of like we can differentiate with the testing purpose and power conversion purpose. But these two types of product, sometimes you can use mixed together, but sometimes it's very different. For example, the power conversion part, usually sometimes you have to do some environmental proof, like a severe circumstance, like if you put on the ocean on the ship, you have a vibration issues and the salt issues, or sometimes you need a waterproof because you put it outdoor. So this kind of power conversions, but usually testing is put it indoor. You will not put it outside. You will not put it test power in the outside, outdoor. So this kind of application, you don't need like a very severe circumstance of that. Okay. Any question, you can let me know all the time. So from the point of view, if you talk about the dollar value for the power supply, of course, like our power supply is very expensive one. But if you go that way, sometimes you will see the different dollar value. If you talk about market size, the embedded power is much bigger market size in the world, because all the power supply, like even like your PC, they have a small switching power supply in there. Even all the equipment you saw are small. But for the market size, that'll be much bigger size. But if you talk about like a motor generator, it's Variac. Variac is like I'm not sure if anyone heard of Variac. Yeah, it's used for like changing the voltage. So a lot of companies, or like even if you want to, because the grid system is like 480, if you want to change to 208, 240, you need to use a Variac different voltage. And then the program power supplies. And grid simulator is that programmable power supplies for the testing purpose. Grid simulator is used like for simulate the grid. It's very similar to AC power supply, but they are more function for grid simulators because they sometimes they need to like bidirectional. You want to simulate the grid because the grid system will absorb the power from like solar system, like wind system. So you have to simulate the voltage and frequency and to observe the power on your PV inverter as well. So usually a grid simulator, sometimes they need like a bi-directional, or sometimes they need to simulate, we call it low voltage ride-through, or like a full ride-through, frequency ride-through. Make sure that your inverter or grid-type devices can work well in that circumstance. And then our power supplies will be more high-end and more expensive. So you can expect that the market size here is big, here is getting smaller. It's a very niche market over here. But the dollar value is higher here, much higher. So that's the difference. So we give you some ideas. So. And for the AC, sorry, here's DC, but the same AC DC power supply is the same. That they have different type. We call like you hear the linear type or switching type power source. So, but everyone, is anyone know the difference of linear or switching type? Some idea?
Well,
yeah, you know,
in the kindergarten. We are engineers mostly here, so I assume we know about it.
Okay, cool. So switching type, we have like a different switch type technology, like MOSFET, IGBT, or SDR. So in the beginning, like, of course, if you heard linear type, usually everyone will think about it's more linear, very clean power source. And MOSFET is like because of the semiconductor, like on the MOSFET, and small power supply usually use MOSFET. But the IGBT grows up very quickly in this like 20 years because of higher current requirements. So everyone think like IGBT can sustain for higher currents. So, but everyone think like MOSFET is faster or IGBT is faster for the response time. Anyone think MOSFET? Why is it not? Anyone think IGBT? Okay, cool. So typically, MOSFET is faster than IGBT. But nowadays, a lot of IGBT manufacturers, like Infineon, like different manufacturers, they are making very fast response IGBT as well. So, but typically, MOSFET is still faster than IGBT. Okay, and SCR type, the response time is slower, but SCR is for different technologies, more like a transformer and SCR in there. So the response time is relatively very slow. But what kind of circumstance you need to use SCR type? One is that SCR is very robust. So for that for power conversion applications, a lot of time we use SCR. For example, if you want to start up a helicopter, it should be like 28 volt DC, right? So that kind of startup, you need something like very high inrush current in the beginning, because when you turn on, you need high inrush current. In that kind of circumstance, you will use SCR type. So for different type, maybe you will use it for different type of applications. And here shows up some linear advantage. Linear type of, give you some idea, the linear type of applications, the advantage of that, everyone knows that it should be low noise, because there is no switching noise on the linear type power supply. So you will not see the little spike there. And everyone thinking a fast response time and design is simple. But the disadvantage will be because it's linear, it's usually very heavy. And the size will be bigger, and the cost will be higher. So when you purchase like the linear power supply from all the manufacturer, you'll find like Kikusui or like even Pacific Power, they have linear, have a switching type, or like other linear usually is more expensive than the switching type, and but efficiency is a little bit lower, should be lower than the switching type. So for this kind of applications, so more linear type nowadays is more like when you're using for high-end testing, very high-end, like you need a very clean power source, you can use a linear type power supply. Otherwise, it will kill your cost. The cost is too high. Okay. So the other one will be switching type. So switching type usually we use like they are rectified in the front end, and we do a double conversion from AC to DC. So that's a typical switching type technology. We convert from AC to DC, and convert to DC to rebuild an AC again. So in that way, here you can use a we call it PWM technology. So we can control a pulse to determine what's the voltage we want to have, and to determine what's the frequency what we want to have. So you can see we call like here we call an inverter module. Here we call a rectifier module. But there are still some difference. Some different manufacturers have different topology of the product. Some people put the isolation transformer in the front end. Some people put it in the output end. But I will tell you more the difference about that. So there are some advantage and disadvantage as well. So and also here some people they have decided not of using the rectifier. They have like 6 poles or like 12 poles. So the rectifier, how much the pulses will affect like input power factor. So because nowadays some people they were concerned about input power factor, or they don't want to the grid system to be polluted by the power supply, the switching power supply. Too many switching power supply will make a lot of switching noise in their grid systems. So So they will do something like a PFC in front, we call like power factor correction. But you can imagine that the more you want to do over here, the higher the cost. So 6 poles will be, 12 poles will be more expensive. If you need a power factor PFC in front, there'll be even more higher cost. So it depends on your applications. Okay. So here you can tell the difference with a linear power supply and SCR power supply and switching power supply. So typically you will see a linear one, you will see a little ripple in the of course, so we call like a regulation rate. So, or like a harmonic noise. So it depends on what harmonic noise. And this, you can see the spike right here. That's switching power supply you have. So, but nowadays, the technology getting better. And we usually the power supply manufacturer will try to make the switching noise as small as possible. So when you see the sine wave, the outputs, you will not see that so obviously. So they will suppress the switching noise very few. So it depends on how much THD. So you can check when you read the specs of the power supply, you can check about the THD, how much THD they can achieve. The lower THD means they have lower noise on that. So that's a application. So, and IGBT have like if we compare about the IGBT and MOSFET, IGBT usually have like a larger current. So a lot like in an EV car nowadays they're using IGBT technologies, and but they don't have like very high switching frequency. So MOSFET usually they can go up to higher frequency, up to 1 megahertz. So the very high frequency. So what kind of applications? What's the difference? So MOSFET, if you see some power supply, it can reach up to 5 kilohertz, 3 kilohertz. Usually made by MOSFET, because MOSFET you have higher frequency switching frequency, and you can make a higher frequency range. But IGBT, you say, well, why everyone use IGBT? It's a lower frequency range, switching frequency, but why everyone still using that? Because it's very robust, and for good for the higher current application. So for like an EV car, you need like a very high power. So you need like a IGBT. So that's a big difference. Like UPS. But small UPS, like a home appliance UPS, some using MOSFET as well. So it depends on the size. If you go to a big one, usually go to the IGBT. The small one uses MOSFET. Okay. Or you need a higher frequency. Okay. So any questions so far? No. Okay. So we give you some idea of now the following we are giving you some idea of the power supply selection. So when you are using power supply, anyone using power supply right now, can you raise your hand? Okay, that's okay. So when you're using power supply, what you need to consider about so I got all the questions all the time, because everyone just asks me how can you choose the right power supply for their applications. So I just summarize some factors you have to determine, and it will helpful for when next time you're choosing power supply, you know how to choose the right one for your applications. Okay, first one will be AC. You need AC or DC for sure. Yeah, that's a very different one. And then the input-output voltage, frequency, and maximum current, programmability, and we will talk one by one. All right. So the first one will be AC or DC. That's a very because AC and DC is very different product. Usually for power supply, some of them they make AC and DC in the same unit. But I can tell you that usually AC and DC in the same unit, there are some limited function in the DC. For example, for example, our MVP product, we call like AC and DC. But AC is a primary for AC. DC is like for providing a constant voltage output mode. But DC product, usually they can have more feature, like you can have like a constant current output mode. You have a constant current power output mode. So if you you have to decide if you are looking for some AC or DC first. Yeah, so maybe you say, oh, if I don't need a constant current power output, or just need a regulate voltage output, you can choose some product with AC and DC at that time. Okay, so it really depends on your applications, and if you are going to do some like testing some batteries or like chargers, for DC one maybe you need some real DC power supplies. You cannot use like AC and DC. Okay. So and the next one you have to choose is about like input voltage, because we know that there are different input voltage in the grid systems. Some of your grid maybe like 208 3-phase, some of your lab only have single phase, some of yours like 240 and 480. 480 usually used in the factories, so factory usually is 480 3-phase. But in different countries are different input voltage, like in Mexico or like in Canada. Canada is like 600 volts 3-phase input, so you have to use a 3-phase 600 volt 3-phase input. And then you have to choose the output voltage. You have to tell the supplier what the output, determine what the output voltage you need. The output voltage really determine on what voltage range you need to test for your test unit. So typical AC source is 0 to 300 volts, which means 0 to 520 volt 99. This is 3-phase, so they have like 1.732 relationship. But if a single phase, you don't need to care about that. It's 0 to 300. Why is like 0 to 300? It's a very typical voltage range, because nowadays all the voltage system around the world were within this range. So like 480, they can cover 480, 380 for the Europe, for like 208 or like 240 for US, for different countries, for like Japan, for like maybe 200 volts. So usually they can be covered in that range. So that's why typical AC source make a product with this kind of voltage range. But only one exception is Canada, is like 600 volts. So when you go to Canada, sometimes we have to go up to 600 volts. And if they are doing some boundary tests, like if you are selling to CSA or like some testing lab, they need to test for the Canada standard. You have to go like plus 10% or plus 15%. So the voltage you have to go up to 690. So that's we will talk about that later. So if that kind of applications, you have to determine your output, but then the frequency. So frequency range, for industrial frequency range, typically you hear is about 45 to 65 hertz. Like 50, 60 hertz is very typical industrial or commercial world. So like our power system is 60 hertz. But if you are going to test in a military, you need 400 hertz. So 45 to 500 hertz is very typical in the AC world. But sometimes the customer will ask for like 800 hertz. The 800 hertz used for new aircraft, like Boeing 787 or like Airbus 380. They need 800 hertz. So you have to determine the frequency range. The frequency range will affect the selection of your power supply. So that's here is the typical structure. So the grid come in onto your power supply, and the power supply will give you you can set up different voltage, different frequency for your test unit. Either your test unit is transformer or any kind of appliances or components, you can change for different type of testing. So the unit can be in the chamber, like environment chamber, or can be in the EMC chamber. So that way, that's typical way for the power supply applications. Any questions? Let me know over time. The next one will be very critical for us when we help you to select the right kVA power supply, because most of the customers they are not realize the importance of the inrush current, and for the no matter it's a linear power supply or switching type of power supply, we will concern about the maximum current you need. So the maximum current, sometimes you will, most of the customer will give you like, okay, like I have a motor with a 10 horsepower, and they expect they just need like maybe 10 kVA of the power supply, but it's not really true, because you have to calculate what's the maximum current. So when you read the motor, the spec detailing, you will see their spec called a rated current, and there is also a spec called an inrush or a startup current on the spec. So why is that? Because when the motor starts, they have a very high inrush in the beginning and go back to a rated current. But most of power supply cannot handle that inrush, so it will trip your power supply off. So some customers, they say, oh, why we buy a power supply but we cannot turn on our, but a lot of applications and motor inside, either like your laundry, or like your motor car, AC motor, or your, everything have all appliances have like a compressor, air conditioner, they all have motor inside. But when you try, if you find like the air conditioner on rated like a 2 kVA, you cannot just buy 2 kVA power supply. You have to read carefully for the inrush current on that. So the power supply need to handle with the inrush. Sometimes the rated current and the inrush, everyone guess what's the difference of that? In your experience, how many times of the inrush typically you hear about an inrush?
3 to 5 times, typically.
Right. 3 to 5 times is very typical. But 3 to 5 times, that's very exactly right. So 3 to 5 times is without any load. It's usually 3 to 5 times. But sometimes the constant is some testing, you have to, like an air conditioner, they have to test with the real air conditioner and they will with the load. So they'll even go up to 10 times. So for example, their rated current is 10 amp, but actually they go up into 100 amp, like a water pump. They will test in the water. So we call that with a load testing. So or like lock rotor testing, you will lock the motor, so the inrush will go very high. So that's why the reason you have to be careful for some power supply. So they can sustain certain overload capacity. So when you read the power supply spec, you can check the overload capacity. So overload capacity, which means if the power supply can sustain like 150%, some power supply can sustain the 200%. But also read carefully the duration. So power supply will tell you, I can handle 200% for 30 seconds, for 1 second. But you have to check how long is your inrush. If your inrush is like within a couple milliseconds is fine, or within 1 second is fine. But if your inrush is keep very long, you have to be careful, otherwise you will blow you out. So this is very important one. When every time I describe to the customer, and they have to be, so sometimes the customer even doesn't know any inrush, how much inrush they have for their test unit. So what can they do? The best way I would tell the customer is that, can you measure by your scope and to check the current. You can power just either on your wall like a wallet, like a outlet or something like that, but you can check the inrush maximum or go back to the original manufacturer. Usually they have the spec of that, and they will test the spec for you. And they will give you the spec of how much inrush they have. So, but in the other circumstance is some machine like a manual machine. They may not have just one motor. They may have like maybe 3 to 4 motors in there. But if their motor will not start up at the same time, they are start up in different times. You don't have to, plan for very, very big one. So if they start up in different time, will be fine. So you can check out with the better ways are they just, check out what's the when it power up, what's the maximum current they have, use a scope. That's the best way to figure it out. Okay. Any question here? Okay, go ahead.
How is the power supply affected by the multiple starts? In other words, the output voltage or whatever you're looking at when another motor turns on.
So usually the power supply, we have a spec called a load regulation. So which means when the load turns on, we will try to regulate the voltage. So when you see the spec of the power supply, you usually will see the regulation rate. So the regulation, for example, this here shows up at 1%, which means that can regulate the voltage in 1% and response for the load. So that's it. But you have to make sure that it's not triple. If the current over your power supply can handle, your power supply you will triple. So when you selecting the power supply for the AC product, usually have like 2 voltage range. Why is that 2 voltage range? You cannot feel like the power supply we have 2 voltage range because one is like usually low voltage range is from 0 to 150 volts. The high voltage is like 0 to 300 volts. So you can switch the voltage range on the power supply. That in the low range, that makes you, in the low range, you can pull out more current. In the high range, you may support higher voltage but lower current. So in the power supply, you have to check that if your test unit were above the value of the maximum current or not. If it's higher than that current, you have to jump to the other one, okay? So the current, again, it should be checked out with your inrush current, not the rated current. Okay, but the 3-phase will be each phase. Usually power supply will show you each phase, how much current you can pull out for each phase. So that's the very, very important. So you can select the different kVA, depends on how much current you need to select the right kVA for your power supply. Okay? Any question over here? The spec or any question in the spec? So then the next one will be the programmable features. Programmable feature, what we usually talk about like it's like you can set up different. So for some testing standards, you need to set up different voltage for certain period of time and rise up the voltage like 110%, and go down to certain voltage and go up to certain voltage, doing kind of like a cycling test. So or like you can ramp up, ramp down. Why I take this out? Because you will only see the programmable feature in the testing world, but in the power conversion world, there's no this kind of feature. They don't need this, right? Because you don't change the voltage all the time. You don't change the frequency all the time. Nobody do that because in the radar system, 400 hertz, 400 hertz. You don't have to test like a 350 or 450 hertz. You don't do that. So that's why some power supply manufacturer, they only make testing power supply. They don't make the power conversion power supply. But if you're using the testing power supply to do the power conversion purpose, using purpose, you will overcharge for that because you don't use this feature at all. But some customers say, oh, the more feature, the better. It's not really because you don't use it, and you'll be overcharged for that. For example, I saw a lot of customers, they put in their aircraft repair shop. They just need 400 hertz. But they buy something like it can do 15 to 5,000 hertz, something like that, and you get overcharged from that because you don't use that at all. Yeah, you can use it, that's right, you can use it, but you don't have to pay that, right? So, and the other one will be, the next one will be communication interface. What communication interface you need is usually communicate with a PC. Nowadays, most of the power supply, if you are using...
I got like 8 minutes.
Okay, I have to speak. So, Ethernet, USB, I232, or like 485. So it depends on what communication you need, and you can communicate to integrate different equipment, and usually using ATEC systems. But before, a lot of people using GPIB. Nowadays, a lot of people moving to Ethernet interface. And actually, in different industry, it's very different. In the testing lab, everyone will asking you if you have a GPIB Ethernet. But if you go to the facility, production line, what interface they looking for?
RS-232 or USB?
Because they 232 can communicate with the PLC, right? Or sometimes they're looking for 0 to 5 volts analog signal to communicate with the PLC. Or 4 to 20 amp. What's the difference with 4 to 20 milliamp? But okay, the difference to 0 to 5 volts control is very easy to affect it by the noise. Current will not be more stable. So if you have longer distance, choose 4 to 20 milliamp will be better for you because it's more stable. And I know most people are familiar with 232, but actually in the facility production line we use 485. The reason, anyone know the reason? Yeah, I have. Right, because I-485 is a differential. I-232, I'm not sure if you're familiar with the 232 signal. If your voltage is a long distance, the voltage will drop, the signal will drop. So for long distance, you may get a long message. But 482 is a differential. So even long distance, you still can get, if you isolate a good cable, you still get a good signal of that. So that's why, in the facility side, like in the military, sometimes they like 482 or like a longer distance. So that's a very different. And now I'm talking about because of the time limitation, I have to go faster. Isolation transformer design. That's very important because everyone knows the power supply, but what's the difference with isolation transformer and no isolation transformer? So you see some, like this is the diagram with the isolation transformer output there. Everyone knows isolation transformer is trying to isolate input and output for your test unit. But why some people make the power supply in the input side, some power supply manufacturers put in the output side? What's the difference? Okay, here tell you the difference. And if you have time, that's we can talk about later in our booth because everyone can. With isolation transformer in the output, usually when you see some smaller kVA, you will. Okay, let's talk about UPS industry. UPS industry, they have like isolation. When you order UPS, like from the, like everyone know APC, like Eaton, you feel like they have like difference with, they call like a low frequency output transformer or high frequency output transformer. What's the difference? If you're using for your industrial purpose, you better choose low frequency output transformer because it's more robust. And it's a real transformer over there, not high frequency. So because in your factory, a lot of motors stuff there, a lot like, you never know what's the testing load there. So if you're using high frequency, like commercial, like your PC, UPS in your production line, or testing the motors, testing the home appliances, you will damage within 2 years very quickly. Because if your motor stuck there, the reverse current come back, you will damage your power supply or UPS very quickly. So isolation transformer, is that for that purpose. So if your application is using for motor related, you better choose with isolation transformer. Some people, they make when they buy the power supply and they buy an additional transformer by themselves, so to do the isolation. But the problem will be, usually they only regulate the first end. So the second end of the transformer, if you set up like 220, the second end maybe not 220 because you cannot regulate the second end. So, but with isolation transformer, the better thing is that you can regulate the second end of the output. So if you set up 220, it's 220. Okay, but the isolation transformer, there are also disadvantages of that. Because isolation transformer manufacturer cannot make a wide range transformer. Nobody can make like a 1,000 hertz. So it's really difficult. So with isolation transformer, usually have like certain range only, because they saturate the transformer. So otherwise, so usually for the isolation transformer, you have to select a different range, like 45 to 65 hertz, or like 45 to 500 hertz. Nobody can make like a 15 to 5,000 hertz with isolation transformer because nobody can do that kind of transformer in the world. So, but with without output transformer, the good thing is that if you want to testing something with arbitrary waveform, harmonic waveform, without isolation transformer, it would be easier to do that. Like a transient test, that would be easier to do that. So it's a totally different applications. Remind me.
Might have like 2 or 3 more minutes and then 5 minutes for questions.
Okay. So this is how it works. So if the power supply, you don't have isolation transformer, you output the motor, and motor stop there. When the motor stops, there will energy comes back. You will easily damage your power supply very quickly because the energy comes back to your power supply. You are not sourcing today. Okay. So that's the benefit for the isolation. The other advantage with isolation transformer is that, as I say, typically it's 0 to 300 volts. But with isolation transformer, it's easier to make for different voltage, like 0 to 400 volts. So you can still put in the same unit, which is rewire the transformer for 0 to 400 volts. And some customers, they need 0 to 1,000 volts for some railway applications. Some customers, they need like 0 to 30 volts. We can make 0 to 30 volt transformer. So it's more, so without isolation transformer, they have to additional cabinet with isolation transformer and hook up with that. So it's not more difficult for them, okay? So here is the applications. So in here, most of the time you will see that typical way, traditional way. If you want to test your unit in there, you will use variac, right? To change like 110, 120, 208. Everyone sees this, right? And yeah, but so you have to turn the voltage. Sometimes you set a voltage. There's the other one is motor type. You have to push it up and down, and maybe take a couple seconds, like a 30-second one, to change the voltage. And you need to change your frequency. You use a motor generator. What difference I tell if you are working in a testing lab, maybe you see this, maybe you are not. Because this is very for the facility size. If they are trying to change the voltage or to change the frequency, they will use this way. You think, why is so stupid? Why they not just buy some, the switching power supply is too expensive. Nobody can afford that for like 100 kVA. If you buy something like power supply for this, it's too expensive. Nobody can afford it. This is too cheap and very low cost. And if they only need to change the voltage and frequency, they will do this way. But the disadvantage of this way is that the efficiency, very noisy because motor is very noisy. And the maintenance for the motors and the size big and very heavy. Harmonic will comes in, if a harmonic comes in, the variate. A lot of my customers, they say, oh, I used variate before, but the problem is I cannot regulate outputs. So nowadays, we can, because of the time issues, so we just give some part of it here, so some details. So nowadays, we can.
So we might have to jump to questions just because of ribs in like 10 minutes out there. Do you guys have any questions for Brian?
Where's he located?
In the booth?
Yeah,
28.
28, okay.
Yeah, you can stop by all the time, we can discuss more.
Does anyone have any questions for Brian? Or? All right, well, thanks, Brian.